Hello students, let us continue our chapter Determinants. In our previous class, we have seen theorem 4, and in this class, let us see our next theorem, that is theorem 5. If any two rows or columns of a determinants are proportional, then its value is what? 0. So all this property we have to remember that if any two rows or columns of a determinant are proportional, then its value is 0. Just see the example. We have given the determinant del is equals to a1, b1, c1, a2, b2, c2, ka1, kb1 and kc1. Okay, so here what we can do, we can take common. We can take k common. So here it will be a1, a2, a1, b1, b2, b1 and c1, c2, c1. Okay, so here what we have seen that if any two rows or columns of a determinant are proportional, then its value is 0. So here we observe that first and third rows are identical. First and third rows are identical. And just now we have seen that any two rows or columns of a determinant are proportional, then its value is 0. So here observing that first and third rows are what? Identical. So this will be how much? K into 0 equals to 0. Okay. Now our next property is if each element of a row or column of a determinant is expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. Okay? If we see that each element of a row or column of a determinant is expressed as a sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. So here just you see the example, del is equals to a1 plus alpha 1, b1 plus beta 1 and c1 plus gamma 1 and a2, a3, b2, b3, c2, c3. Okay. So here you can arrange this as what? A1, A2, A3, B1, B2, B3, C1, C2, C3, and this you can arrange as A1, alpha 1, beta 1, gamma 1, A2, B2, C2 and A3, B3, C3. In that way we can arrange. Our another property is if to any row or column of a determinant, a multiple of another row or column is added, the value of the determinant remains the same. There will not be any change in the value of the determinant. So here del is given. We have given this one. If we want to add k, okay, a1 plus ka3, b1 plus kb3 and c1 plus kc3, and others will be same, a2, a3, b2, b3, c2, c3. So this can be arranged in this way, a1, b1, C1, A2, B2, C2, A3, B3, C3, and this K1 part we can arrange here as we have done previously. Okay, and again this will be similar to our del, because since second determinant is 0, its first and third rows being proportional. Our next property is the sum of the products of the element of any row or column of a determinant with cofactors of the corresponding elements of any other row or column is 0. This property we have to keep it in our mind that the sum of the product of the elements of any row or column of a determinant with cofactors of the corresponding element of any other row or column is 0. This we can see in this example. A11, A12, A13, 21, A22, A23, A31, A32 and A33. So here if we will arrange, then our value will be 0. Okay, so here we can take the sum of the products of the element of first row with the cofactors of the corresponding elements of the second row, and our value will be 0. Okay, and in the next class we will see how we will find the value of a determinant. So this much for this class, and rest in the next class. Till then, have a good day.